Hey guys, today I'm going to teach you how to solve systems of equations by substitution. This is part one. By the end of this lesson, you'll be able to solve a system of equations by substitution. That means you're not going to be graphing today. So this is all about different strategies to solve systems. Last time we looked at graphing. If that wasn't your thing, this could be your thing. If you thought it took too long to graph, this could be even better. Substitution is another way to solve a system. So go ahead and get out your binder, turn to the math section, and let's get ready to take some notes. So just to review, so far, I told you there would be three ways to solve a system of equations. The first one we've already gone over. It's by graphing, and we found the solution by graphing two lines and then finding where they intersect. Today, we're going to learn how to do that by substitution. The other thing we know so far that we discovered when we graphed is that there's three types of solutions that you'll get. Remember, a solution's where they intersect, or in some cases, they don't intersect. So sometimes you'll have one solution where the two lines will cross and X marks the spot. Sometimes you'll have no solution if the lines are parallel or have the same slope. They'll never ever touch, so they'll never intersect. Or sometimes you'll have infinitely many solutions where you'll be looking at what you think is just one line. If it tells you there's a system, it means they're the same line just on top of each other. There's two different lines, just written differently maybe, but they'll have the same slope and the same y-intercept. So you could have three types of solutions. One solution, no solution, or infinitely many solutions. Again, a solution is just where the lines cross. So I always think about two lightsabers crossing. Or in a real life example of like a tortoise and a hare, it's where they catch up to each other or where they are the same. One problem we looked at that was actually pretty difficult was this problem. This was our hardest problem on part one of solving by graphing. And what we did was we realized that these two equations were not both written in slope-intercept form. The first one we needed to convert into slope-intercept form, and then it takes some time to go through and graph. And then sometimes we don't always graph perfectly, and it's kind of difficult to see exactly where they intersect. So we ended up with this, two graphs that intersect, and we had one solution, and that was at 2, 2. And we found the solution. But if I asked you to do that by yourself, without showing you the answer, would you be able to? Would you remember to do that? Could you figure out how to write this standard form equation and slope-intercept and graph it, then graph the other one, and blah, blah, blah. It's too much. Sometimes substitution is an easier way to solve these types of equations. Let me show you how. We're going to use this first problem as an example because it's one we've already done by graphing, but it'll be easier to do by substitution, I promise you. So stick with me. We're going to keep coming back to this example here. Here's step one. It says solve one of the equations for y equals if necessary. So we're just going to follow some instructions. This is step one. Solve one of the equations for y equals if necessary. One of them is already set to y equals. Nothing else we need to do. Let's move on to step two. Substitute the value for y in the second equation. Now what does that mean? Let's look back here. So substitute means to put something else in place of it. If I've got a substitute, I've got someone else coming in to take my place for the day. So what I have here is two equations where I have x and y's. Let me underline the x's in red, and I'm going to underline the y's in blue. All the x's equal the other x's. The y equals the y. So what I can do here is substitute what y equals here into what y equals here. If this y equals this, then instead of writing y, I can write this. Let me show you. This is the first equation, negative 6x plus 2y equals negative 8. This is the same thing. This is a y, and if this y and this is a y, they equal the same thing. Y is a y. So instead of writing y, I can write what y equals. Since this is the same thing as this, that's what an equal sign means. So again, instead of writing y, I am going to write in what is written here that y equals. Negative 2x plus 6. Again, this y equals negative 2x plus 6. If this y is the same thing as this y, then this y is negative 2x plus 6. That's substituting. That's when I said this is this, so this is this, and I'm just going to put this in for this instead. It sounds confusing, but once I've got it written like this, and all I did was substitute in what y equals for y, now I only have one variable. And if you remember from solving equations, when you only have one variable, you can simplify and solve for that variable. So that will be our next step. Solve the new equation to find x. If you need to, pause the video, replay that part, take that in, digest that, think about what I just did here and how I ended up putting that in there. And if you need to, please ask me for questions or for help or whatever, because I'm about to go through this and solve. So when I solve this, I realize that I've got a number on the outside of a parentheses. So I'm going to distribute that to each term on the inside. So what I'm left with is negative 4x plus 12. And I'm going to bring down everything else. So negative 6x gets brought down, and the equals negative 8 gets brought down. And as you know, I always want to separate my equation with a line down the equals. So that separates that I know that this side and this side need to be balanced. So when I look at the left side here, I'm going to simplify anything I can simplify. So I have a negative 6x and a negative 4x. I can combine those like terms. So now I have negative 10x plus a 12 equals negative 8. Now I can't simplify anything else on the left. There's already a negative 8 on the right. So I'm going to make sure I get all my x's on the one side and my numbers on the other side. X's are already on the left, so I need to move away all my numbers, every number that's on the left. So I'm going to start by getting rid of my plus 12. I'm going to use inverse operations. So I need to get rid of a plus 12 with a minus 12. And if I do it to one side, I have to do it to the other side. So now I'm left with a negative 10x equals negative 8 minus 12, which is negative 20. The next step here is that I know this is negative 10 times x because it's a letter next to a number. So I need to divide by negative 10. That's the opposite of times negative 10. And I'm left with my x on one side all by itself, equaling negative 20 divided by negative 10, which is just a positive 2. So now I know what x is. Just pretty quick here, but just going through it again. If this y is the same as this y, then I can plug in what y equals into the equation up top. Just use one equation to solve this. When I have one equation and one variable, I can use my rules like distributing, simplifying, solving the two-step equations and figure out what x equals. X equals 2. Now that I know what x equals, I can follow my rules here and go to step 4. Substitute the value for x in either of the original equations to find y. So I've got two equations here. I've got a lot of messy things here, so I'm going to go ahead and erase that. I've got two equations, and I'm going to substitute x equals 2 into one of them. If this x equals 2, then this x should equal 2, and that x should equal 2. I'll use the second equation, and I'm going to use this in orange here. This equation should have an x that equals 2. So instead of writing x, I'm going to write 2. Notice that I just did that. Instead of writing an x, I wrote 2, since that's what x should equal. And then I'm just substituting in that 2 in for the x. Now I can solve because I only have one variable. So y equals negative 2 times 2, which is 4. Negative 4, excuse me. Negative times a positive is negative, plus 6. So negative 4 plus 6 is 2. So y also equals 2. Now that I have an x and a y, I have a solution. Remember, every solution is a point. So my point is always going to be x comma y, or in this case, 2 comma 2. I just solved this system of equations by substitution. But remember, we already solved it by graphing. This is what it looked like when we graphed it, and we already saw that we had a solution of 2, 2. So when we graph these two lines, anytime I have a y equals or an x and a y together, I have two lines. And the solution by graphing was the point where they intersect at 2, 2. But remember, it was more difficult because this first equation was written in standard form. So instead of solving by graphing, we solved by substitution. And we got the exact same answer, 2, 2. So looking back at step 5, I always want to end anything algebraic by checking my work. You can check your answer by substituting the x and y in both of the original equations to make sure they're both true. So like we were doing with graphing, you could also check by graphing. You could also plug this into your calculator and check it by graphing. So I know that was a lot of work, but if you have a hard time graphing or you can't graph, then substitution works just the same. You'll get the same answer by substitution if you do it correctly. So let's look at some more examples. I've got 3 of them here. We'll solve each of these systems by substitution and then check our work. And we can check that again by plugging in the x and y values into both equations, or we can check by doing the graphing method. So we'll do it both ways. Let's start with number 1 here. I have a y equals 3x, and I have an x plus y equals negative 32. Step 1, solve one of the equations for y equals if necessary. This one is already set with a y equals. The second step is to substitute the value for y equals into the second equation. So this top y equals 3x. A y is a y. So instead of writing y, I can write 3x into the second equation. So in the second equation, instead of writing a y, I will write 3x. Again, this y is the same thing as this y. This y is the same thing as 3x. It's better for me to write 3x here as y, so I only have one variable. When I only have one variable, I can solve an equation. So I'll draw a line down the equals, realize that 1x plus 3x's is the same thing as 4x, and then I'm going to solve for my x. I'm going to do that in this case by dividing by 4, since it's times by 4. So I'm left with x equals negative 8. That's what negative 32 divided by 4 is. So I solved my equation for x. Now the last step is, now that I have an x, I need to find my y. So I substitute the x value into either one of the equations to find y. I'm going to choose the easier equation, y equals 3x. So I'm going to rewrite it as y equals 3. But again, instead of writing an x, now I know that x is negative 8. So I might as well write negative 8. And then 3 times negative 8 is negative 24. That's what y equals. So it's like you're solving a puzzle. So now that I have an x value and a y value, I have a coordinate, and xy is an ordered pair. So I'm going to write it as an ordered pair as negative 8, negative 24. That's an xy ordered pair that makes these equations true. I can double check that by plugging in the negative 24 in for the y and the negative 8 in for the x, and they will both come out true. I can also check by graphing. So for the sake of time, I'm not going to do that. I would ask you to do that. But for me, I'm just going to move on to this one because this is another example that you might see. On number 2, both of these examples or equations are set to y equals already. If they're both set to y equals, then I can substitute the value for y in the second equation. So this y equals 9x minus 2. If y equals 9x minus 2 and y is the same thing as a y, I can plug in 9x minus 2 in for the y in the second equation. Now I have an equation where there's a variable on both sides, but it's the same variable. 9x minus 2 is the same thing as 3x plus 10. Y equals y, so this equals this. It's just logic. Now I'm going to solve for my x. I do that by picking a side for my x's and then picking a side for my numbers. And then I solve for x. So I need to get rid of the 3x's on this side by subtracting 3x's. So that leaves 6x's on the left. And then I need to get rid of the minus 2 on this side because it's supposed to be my x side. So I need to get rid of minus 2 by adding 2. So I'm going to plus 2 to both sides. So I'll have 6x equals 12. I know that this means times since there are a number and a letter next to each other. So I'm going to divide by 6 here because it's inverse operation to solve for your x. So my final answer will be 12 divided by 6, which is 2. So I have an x equals 2. Now my next step, once I find x, is to substitute the value for x into either one of the equations to find y, and you'll get the same answer. So I'll just pick the second one just because I chose to. And again, this method is called substitution because if I see an x, I can substitute in what I know x is. I know x is 2. So I'm going to substitute a 2 in for x. So it's all about using your logic skills. If you know what x equals, you can figure out what y equals here. So y equals 3 times 2 plus 10. 3 times 2 is 6 plus 10 is 16. So now I have a coordinate because I have an x and a y. So my final answer will be the point 2, 16. Remember, that's an ordered pair because it's x comma y. This is the point that these two lines would intersect. And again, you could check this by graphing. In this case, they're both set in slope-intercept form. So you could just graph both of them and see that they intersect at 2 comma 16. However, if you don't have a graph that's big enough, or if you can do this algebraically, it would save you some time, especially if you don't have graph paper or you don't have a graphing calculator. You know, there's so many different instances where substitution is actually faster and easier. So I'm going to let you try number 3 on your own, and then we can start next class by checking that. Please message me a picture of that or send that to me or show me if you want to check that real quick, and then I can go over that with you individually. All right, guys, that's it. If you made it to the end of this video, please comment your favorite prime number. Today, we did part 1 of solving systems by substitution. So now you should be able to solve a system of equations, not only by graphing, but by substitution. So you don't actually need to graph to solve systems. You can do it algebraically. I know it's kind of confusing, so again, please ask me questions if you need help. And now you should go back to the calendar and complete any other assignments you have left for the day. Please let me know if you have any questions. Bye.